So the last tool we're going to go over in topic 13 is the reorder point. This is one of the most tricky areas to get right when we're managing inventory. So let's get into it. So our reorder point is not a simple, well, we order it when we run out. If you do that, it's not going to happen. There's a lead time. So trying to figure out when to place that order. That's what the reorder point is there to do for us. So that reorder point factors in the lead time. And if you have any time, let's say from when it hits your dock to when it's actually available in the system. So you want to add all that time together. That's the lead time. So you don't want to order when you run out, because then you're going to be out for a number of days or hours or weeks. So when we set that order, we have to make sure of a few things. So our lead time, to just a very generic way to figure our reorder point, is our lead time times the daily average of demand. So if we're selling 10 units a day and the lead time is 3 days, well, we should make sure we place that order when we only have 30 left. Now, this is not factoring in any variations in demand. So think about yourself when you look at your refrigerator and you have, let's say, have a gallon of milk. Well, at what point do you go ahead and get another gallon of milk? Do you wait till it's empty and then, like me, probably forget to get milk that day? Or do you wait till it's about 25% left and then you go buy another gallon of milk? So that way, when that 25% of that milk is gone, you have a brand new gallon ready to go. So this is very applicable to your own lives. So we have to establish a service level policy. So here we have a graph that shows our inventory level, our reorder points, and it's not a straight line down. There's a variation in the demand there. So we have some uncertainty here. But we have the formulas to make this work for us. So we have to figure out and determine the level of demand variability during that lead time. Is it all over the place? Are we selling one item a day and then the next day selling 100 units? Is sales about to have a push to sell this item? Or are they slowly not selling this item because a new item is coming in and they're trying to push that one? So all these factors will go in, but we're just going to look at demand, what the customer is actually ordering. So here, this service level is right at 50%. So by looking at this, we're going to be out of the product 50% of the time when customers order it. So we have our demand, our average demand over and our lead time here with our reorder point at 50%. So like I said, half the time we're not going to have the product available. So we have different service levels here. So with a 90% cycle service level, we'll run out 10% of the time. And then we have a Z value, a Z score for all these values. So these are also known as the sigma, our standard deviations from that center point. So as we move out, we're only considering half of it here, but you can see it's 1.28 sigma, 3 sigmas. But the higher you get, the more inventory you're going to have on hand. So you have to find the happy medium. What is acceptable to your company when it comes to stockouts? Is it acceptable to have a 10%, or is it just plain not acceptable? And maybe you go for the 99.86 service level. So we have to figure out what your company wants. So we have a formula here. It looks complicated, but it's really not. So to look at our standard deviation of demand, sigma D, sub D, and then we have our lead time. So it's going to equal the square root of our average lead time, the bar means average, and then sigma of our demand, our standard deviation of demand. We're going to square that. And then we're going to add our demand, our average demand, and we're going to square that. And then we're going to square the sigma of the lead time. So the standard deviation of lead time. It looks more complicated than it is. really we're only looking at 4 things. So if we look at this scenario here, imagine that your average daily demand is 12 units per day. Okay, so we know that we have 12 units per day. That's our average daily. So that went right in here. However, when you're looking at the data, you know that on a slow day, demand is only 5. So on the low end, we're selling 5 a day. If busy, we sell as many as 18. It's a huge difference there. That's a 13 unit difference. You calculate the standard deviation of demand to be 1.7 units per day. And you see that right here. You did a similar analysis for incoming supplier delivery lead times. You discover the following. The average delivery lead time is 8 days with a range of 3 to 15 days. You might want to talk to your supplier about that, having a 12-day range there. And a standard deviation of 2.3 days. So 8 days, give or take 2.3 is the average. So it could be 10, it could be 6. So what do these numbers tell you about your demand during lead time? So this 2.3 days, the standard deviation for lead time, went over here. So we're selling 12 units a day, but it could range 2.3 days on either side of that when we place an order. But our average delivery time is 8 days. So far, I hope this makes sense. So when we do all this math, it comes up to 28.02 units. So this would be, for in all essence, our safety stock. But we'll get more into that. So even though during the lead time we'd have 96 units that would be sold, that'd be the 12 units per day, our average daily demand, times our average delivery lead time, 8. So 12 times 8. But we have our highs and lows. So we might need as little as 15 units. So the lowest daily demand of 5 times the shortest delivery, 3. So that'd be 15 units. But on the high end, could need as many as 270 units. 18 units a day that we're selling and waiting 15 days for it to come in. So you see the huge range here. But when we use this formula, we came up with 28. So here's our formula again. And as I explained, we come up to 28. So our average lead time, right, was 8 days. And then we had our standard deviation of demand, which was 1.7 units. So then we square that because we had the sigma squared here. And then we're going to add the 12 units. So the 12 was our average demand. And then we're going to take the sigma of our lead time. So we have standard deviation of our lead time. If you remember, that was 2.3 days. And then we're going to square it because that's how it's in our formula. And this is going to give us our standard deviation of demand during lead time. So this says that we can give or take 28 units. All right. So our reorder point. What is all this for? So we have our average daily demand, which was 12 in that other scenario, multiplied by the lead days, or lead time in days, which was 8. So we'd have 12 times 8 plus our Z, which would be our standard deviations to achieve our cycle service level. Now this is going to be that 1.65, 3, those different numbers, depending if we're going for a 90%, 98%, a 95%. We have to go back to that Z-score and figure that out. So our sigma of our demand and lead time. So we have a standard deviation of demand during lead time. All right, so we're going to go a little bit further with this. So we calculated our economic order quantity from the last topic for Wildcat headphones to be 404 units. Assuming that the demand is normally distributed, our average demand is 12 units per day, 12 headphones per day, with a standard deviation of demand during lead time of 28. We just did that formula. And then we came up with 28.02, so we can round that down. If your headphone supplier offers an average daily lead time of 8 days, just like our previous scenario, and you want to maintain a cycle service limit of at least 95%, what is your reorder point? So if we went back and looked at 95, that'd be our cycle service, or our z-score, I should say. Our z-score would be 1.645. So let's go ahead and start throwing these numbers in. So we have 12 units, our demand, our average demand, the D bar, lowercase d bar, is 12, right? And then they said it's going to take us an average lead time of 8 days, so LT, lead time. So 12 times 8 is 96. Then we got our Z, so remember the Z score, which is our cycle service level Z score. So Z would come up to turn into 1.645. And then we're going to multiply it by our standard deviation of demand by lead time, which we came up here. Standard deviation of demand during lead time is 28 headphones. So when we do this, it comes up to 46.2. Add them together. So our reorder point is what we're going to set in the system to let somebody know is going to be 142.2. That's the correct answer, but you can't have 0.2 of a unit, so we're going to round it up because it's always easier to round up to 143 units. So this reorder point would be 143 units, this line right here. And based on our math, it's going to cover 95% of the orders that we get. So if we wanted to hit 98%, we'd have to do the math again with different numbers and see where that lined up. But we're only going for 95%. So if we had a reorder point of 143, that essentially guarantees we will not run out before the next delivery comes in and the inventory is accounted for. So when we look at this 46.2 is our safety stock. So this is like a buffer that we give ourselves, because remember, when we go back, so when we went back, we had a delivery standard deviation of 2.3. So that 2.3 is that 46.2. So that's factoring in that deviation there. I hope that makes sense for you. All right, so when we plug it in, so what is our total annual inventory cost? Now this is factoring in safety stock. So we have our cost of holding, our annual holding cost, and then our annual order cost. So demand over quantity times order cost. Then we're going to add in our safety stock. That's what this part is. And then we're going to times it by a holding cost. So these numbers, using 404, because that's what we said our economic order quantity is. So we have our quantity, so 404 divided by 2, multiply that by 6, because 6 is our holding cost. Then our demand, or annual demand here, is 6,500 units. And our quantity that we're ordering at each time is 404. And it costs us $75 per order we do. And then we have our safety stock. So we round it up because you can't have a decimal in your safety stock. You can't order a decimal of a unit. So especially you don't want to have half a headphone in this scenario. So we round it up to 47 times our holding cost. So 47 times the holding cost. So when you do all the math, it comes up to $2,700 is our annual inventory cost. So it's relatively simple, and I hope that I explained it in a way that works for you. So if you have any questions, send me an email and I'll be happy to answer them. If we need to set up a Zoom meeting, that's perfectly acceptable as well. So I look forward to it, and this is the last topic of last section of topic 13. So give me some feedback. I'd like to know what you guys liked about these videos, what you didn't like about them, and hopefully the next set of videos I make will be even better. All right, thank you.